Go ahead.
Can we do homework number three?
I start recording. This is a disaster. All right. So I want to note that if you try to plug in now, you're gonna get 0/0. So it's very simple. Use the identities I gave you. Remember, you're gonna be allowed to use that cheat sheet. Where tan is, you're gonna put sine over cosine divided by, right? It's tangent, it's a sine over cosine, divided by secant, which is 1 over cosine. Then you do keep, change, flip. So you're gonna have sine over cosine. That's going to change to times, and then that's going to flip over to cosine over 1. Then I'm going to knock this out, and I'm going to knock that out. And I just get sine x as x goes to pi over 2. When you put pi over 2 in there, that's 90 degrees. The sine of 90 is a 1. So it's that simple. So all you had to really do there was just pop in sine over cosine for tan, 1 over cosine for secant, and do the whole keep, change, flip thing. And then you're
Okay.
good to go. All right, I'm going to pause it now so you can talk if you want. All right, and look, I'm gonna mute you all so you don't talk while I'm doing it. All right. Yeah, of course. Fucking Zoom. It used to be really easy to do this. All right. They completely changed. And then when I'm finished, if you want to ask me something. So look, you have to. There are three things. The way the derivatives on the test are going to be set up is just like this. They're 1 point each. You either get it right or you don't. So, but the first step, and this is important. The first step is to rewrite this in a way that I can use the power rule. What I'll see students do is they'll rewrite it, and then they'll think that that's the derivative, and then they'll stop, which is ludicrous. So you're going to have 3 here. Now, on the bottom, I'm going to write this, and then I'm going to rewrite it. The root always goes on the bottom of the fraction. And this is x to the 5th. Look, x to the 5th, x to the 5th. Very easy. That 3 is the root. It's a cube root, so it goes on the bottom. Now, my power rule doesn't work like that. My power rule works like this. So I cannot leave it there. So what I'm going to do is I'm going to bring it up by switching the sign of the power. So now that's going to become negative 5/3. Now, over here, you have to be very careful. First, I'm going to deal with the fraction. There is an invisible 1 there. Yes, ninth root, but it's 1/6. So I'm going to write 1/6. I'm not going to leave it the way that it is. Now I have x to the 4th power. I mean, it's right there. X to the 4th. The root is 9. So just put a 9 there. Very simple. Same thing over here at the end. I have 8, so I'm going to put it in the front. On the bottom, I have x to the 1st power. And then the root is 4. But it's on the bottom. So I got to move it up as minus 1/4. So that is your setup. You haven't done a damn thing yet. You have not taken a derivative yet. This is the setup. You rewrite, and then you do one at a time. I'm going to do the power rule. I'm going to multiply by the power. So I'm going to do 3 times, now be careful, negative 5/3. Then I'm going to subtract 1 from the power. Hope if I write it correctly. X, I'm going to do minus 5/3 minus 3/3, right? That's 1. Then I'm going to put a plus here. Multiply by the power. You got to do this very precisely because it's really easy to fuck this up. 1/6 times 4/9, x to the 4/9 minus 1, which is 9/9. Always just whatever the bottom is, it's just that over itself. Over here, I'm going to do positive 8 times the power, which is negative 1/4. And then I'm going to subtract 1 off that power. And again, this time I'm going to pick 4/4. All right, I should have put my parenthesis there. Now, very carefully, the 3's crossed out, right? 3 divided by 3 is 1. So you're just left with negative 5. Now subtract them. Negative 5 take away 3 is negative 8/3. That's that power. Over here, again, you got to be super careful. I have 4 and I have 6. They're both divisible by 2, so cut them in half. Now I do 1 times 2 on top, 3 times 9 on the bottom. And then I'm going to do 4/9 minus 9/9. So it's 4 minus 9 on top, which is negative 5. 9 on the bottom. I mean, these are really easy to screw up. You got to be super careful. Over here, I'm doing a positive by a negative, so that's negative. And I'm doing 8 divided by 4, which is 2. Right? 1/4 of 8 is 2. And it's negative because that's negative. And then I'm going to do negative 1 take away 4, which is negative 5/4. I mean, it's so easy to mess that up, but that's one at a time. I do it nice, I do it slow, and I do it careful. All right, so the one on your test, the one on the review sheet has x equal 4. There's a reason though that I don't put that on the test. Students can't do this. Like I even in my top 2 class when I'm giving them something like this, they'll tell me it's 4.5 because they'll just take half of 9. So a student will do this wrong. They'll just cut 4 in half and get 2. Now, the square root of 4 happens to be 2. So, and I know that. I know that a student will fuck it up and just cut the number in half, which is wrong because it's an exponent and it's a radical. So I don't pick 4 for that reason. I pick a number like 16, knowing that if they do half of it, they'll get 8. But that's not the right thing to do. So watch, I'm gonna go through this one. So again, the first step was to find the y value by plugging in the number. So again, I'm changing it from what's on the sheet. On the sheet was a 4. So here I'm putting in 16. Square root of 16 is 4. So you're going to do 2 times 4, which is 8, minus 3, which is 5. So that's the y value. So that gives me the point x is 16, y is 5. Now I got to take my derivative of this. But before I do that, I'm going to rewrite it. I'm going to take this and make it 2x to the 1/2 minus 3, because that's what the square root means, right? It means 1/2 power. So now I'm going to multiply by the power, which is 1/2, and then I'm going to subtract. Oops, I'm going to subtract 1 off the power. I'm going to show everything. I don't like to skip steps when I record it. So multiply by the power, subtract 1, and then the derivative of that is 0, so it goes away. I don't write it at all. Now I'm going to neaten this up a little bit. I'm going to cross those out. I'm going to do 1/2 minus 1, which is 1/2 minus 2 over 2. So that's negative 1/2. So my derivative is 1x to the minus 1/2. That's my derivative. Now I don't want to leave it like that because I'm going to plug into it. So I'm going to take my derivative. I'm going to write it in a way that I can plug in. First, I'm going to take my negative power and I'm going to flip it downstairs so that the power changes to plus. I cannot do a negative power. I have to make the power positive so I can compute it. Then I'm going to write the 1/2 power as radical x. So that's really my derivative. Now I'm going to plug the 16 in there, and I'm going to get my m. So my m is going to be whatever I get when I plug 16 into my derivative. So that's 1 over radical 16, which is 1 over 4. This is the reason I don't put x as 4, because the student will get here. They'll do this. The student will put the number there, and then they'll either tell me it's 8, or it's negative 8, or it's 1 over 8, but they'll fuck it up. Like they'll do that half power wrong. And if I put a 4 there, they'll do it wrong and still get it right. And that's not understanding. So that's the reason I don't pick 4. And that I'm telling you on the test it's 16. So now I have it all. I have a point that my tangent line goes through. I know the slope of my tangent line. So I'm going to write my y equals, it's mx plus b. So it's 1/4 x plus b. Now I'm going to put my y, which is 5, over here. I'm going to put my 16 over here. That's my x. And I'm going to solve for b. 16 divided by 4 is 4. And then I'm going to subtract 4 from both sides, and I get b equals 1. So that means that my line is going to be my slope, which is 1/4, and then my b, which is 1. So I did all the steps I showed you in class. Plug in x to get y, my point. Take my derivative very carefully, because if you fuck up the derivative, you lost almost all the points. After I have my correct derivative, I plug my x into it. That gives me my m. And then I just solve for b, using the slope that I got and using the point that I found. I mean, you had to find a lot of that on your own. I mean, I gave you nothing but the x and the function. It's there. Whoops. Okay. So this one is also on the test. So it's important though. If I said x goes to pi, then you don't get 0 over 0. And that rule that I taught you doesn't work. X has to go to 0. So then you have to split up the top. Sine squared 3x means that you're going to take sine 3x and multiply it by sine 3x. That's what it means to square something. It means you times it by itself. Not sine x, right? The angle is not x. The angle is 3x. Now, but you got to be slick here. This x squared you have to split up as x, right? X times x is x squared. This is the trick to this question. Because I taught you how to do this one. That's 3 over 1. But you have it twice. So that limit is 3. That limit is 3. And you're multiplying them because x times x is x squared. So you get 9. I mean, it's that simple, and that's all I want you to do. That's exactly what I want to see on your exam. I don't need to see anything else. Nothing crazy. Don't try to put this 3 in the front. I see students do it all the time. They take this 3 and they go move it in the front. They write sine 3x over x. This is completely different. This is bullshit. This is not equal to this. So you can't write that. As soon as I see you write that, I have no choice but to deduct the point. So don't write anything other than what I just wrote. This is it. Fucking question is that simple. You split up the sine squared, 3 or whatever it is. I might have sine squared 4x or 5x. 5x. So you just do 5 times 5, get 25. Whatever the number is. If it was sine squared 4x, then it would be 16 because you end up doing 4 times 4. So this limit 1 with the fractions. All right, so the ultimate goal, right? If I put 3 here now, I get 3 minus 3 on the bottom of this fraction, and it's over. A 0 on the bottom is death. So my ultimate goal is to make that go away. I can't have that there. So I have to make the fractions on the top the same. And look, it's very simple. Whatever bottom is here, you put on this side. Whatever bottom is here, you put on this side. It's that simple. That is my new LCD, right? That's my least common denominator. I times this side by 3. I times this one by x. Now, you don't times it like this. That's 3 over x. That's not 3 over 3x. And I look for this. And if you fuck that up, you're going to lose a point. This is the first thing I look for when I grade it, is that you multiply to make the bottoms the same. Now, on the top there, you get 3 over 3x. Take away x over 3x, all over 3 minus x, right? I made the bottoms the same. Now that I did that, I can take these two and combine them into 1. So I'm going to keep the bottom the way that it is, which is 3x, and I'm going to do 3 minus x on the top. And I am dividing that, right? Dividing that by 3 minus x. I mean, I think you see what's about to happen. I'm going to do my keep change flip now. I'm going to write, and again, I got to write lim. Write this till you plug in. If you stop writing it and I write it on your paper for you, minus 1, it's going to be there. You know, I might let you get away with it one time, but if you do it on every fucking limit, I'm going to get annoyed and I'm going to keep writing it, and then I get annoyed and I take a point off because it's not right. You don't stop writing the lim until you plug in. So I have keep change to times, flip that over, right? There's an invisible 1 under it. So when I flip it over, I get that. Now I am crossing away these. I'm not canceling 3, 3, x, x. I am crossing this entire quantity out. Don't forget to put little 1s there. Now, this is where people screw up. It's very easy. People will write this down. They'll just put 3x. But it's not 3x. It's 1 over 3x. And again, you make that mistake, it's a point. I mean, it's not right. So now, I am at the point where I'm going to put 3 in. I stop writing lim, and I just plug the number in. So you do 1 over 3 times 3, which is 1/9. I mean, it's involved. There's a lot to this. You got to make the bottoms the same, and then you got to combine them. Then you got to do the keep change flip. You got to cross out. Now, you might have to factor here. That bottom on the test, it might look like this. So then, in this case, you would factor out the 2, which would allow you to cross out the tops. And then you would end up with a 2 there, right? You might have to factor this bottom in order to cross out. This might be factorable. You know, it might not be quite as simple as the one I just did, but that one is there for sure. That's, you know, there's no getting around it. I know I have that one there. This is the other limit that's on the test, and I do consider it pretty difficult, and it's gonna take me a little bit to get through, but I want to show you everything that you have to do. As soon as you see the radical, you know that you're going to be doing conjugate. So what you do is you write exactly what you see on the top and the bottom. And then all you do is switch whatever's here. If this was plus, you'd write minus. If it's minus, you write plus. That is what the conjugate is. You make a copy of what was there and you switch the sign in the middle. Those are conjugates. Now, I have to times this all out. This is the part that's a huge pain in the ass. So I'm going to run through it now. You cannot skip timesing these. The bottom, I am not going to multiply the bottom. You cannot multiply the bottom. You're going to get a disaster. So the bottom I have to leave the same. My goal, look, if I put 8 here, I get 8 minus 8, which is 0. My goal is to kill this. I know if I do the top correctly, it's going to eliminate the bottom. So now I'm going to do my FOIL one at a time. My first, I'm going to do radical x minus 4 times radical x minus 4. That's x minus 4. This is where people fuck up and they get very lazy, and I don't like laziness. I like everything written. I have to do radical x minus 4 times positive 2. He is not in the radical, so he has to stay in the front. So I get positive 2 radical x minus 4. Now I have to switch to this dude, and I have to do negative 2 times radical x plus 4. Minus 4. So you get minus 2 times radical x minus 4. I didn't make my line long enough. And then at the end, I'm going to do minus 2 times plus 2, which is minus 4. That product has 4 terms. I see people get very fucking lazy with this. And they just write this and this. Because they're like, oh, the middles cross out. Yeah, they're going to cross out. But part of this question is me testing. If you understand how to do this product correctly, first, outer, inner, last. That product has 4 terms. Now, these cross out. You have 2 radical x's, minus 2 radical x's, they go away, right? I know it's x minus 4. So they're identical. You have 2 of them, you lose 2 of them. They're gone. So now you just get x minus 4 minus 4. Look what's left. This dude, take away that dude. That's x minus 8. That's exactly what you want and need to knock this one out. My 8 looks all screwed up. You need x minus 8 on the top, and that's exactly what I got. Now, this is where it gets very dangerous. You got to be very careful when you do your crossing out. So I have radical x minus 4 plus 2. So now I'm going to cross out the ones that are the same. I'm going to put a 1 here because people will cross them out, and then they'll write this down. But that's not where it is. It is on the bottom of this fraction, and there is a 1 on top of it. So you have to be really careful when you do it. So after I cross out, now I'm not ready to plug in yet. So I have to continue to write my lim until I am about to plug in. So there you go. It's time for me to go. So I get here. I'm going to plug 8. Now lim goes away. Put 8 where x is. And look, this has to work out nice. I made it work out nice. You're going to get 4 there. You have to get a perfect square. And again, be careful. This plus 2 is not in there. It's outside there. So, right, 8 minus 4 is 4. Square root of 4 is 2. You notice that I don't skip anything. I write every single step, all of them. Now, I know many of my students like to go from right here to right there. I don't like that. Now, I'll let you go from here to here. I'm not going to have a heart attack. But if I take the time to write out, look at everything I wrote out. Every fucking step. Every step. All of it. Now, it's a lot. When I make my answer key, I do the same fucking thing. I write it all out just like you would. And I'm looking for this when I grade it. This is how I grade it. I'm looking for that work. I'm looking for understanding. Do you understand what the hell you're doing? Do you know what the conjugate is? Do you know how to multiply the conjugates? Do you understand that after you cross out, you get a 1 on the top, and then you plug in? This is what I am looking for when I grade it. So that's why that question is worth 3. If a lot of that work is not there, you're going to lose like 2 points. It's very simple. I almost don't even give a shit about the answer. You could screw up at the end and tell me it's like 1/8 or something, and whatever. I might not even take off a point. The answer is almost irrelevant. You did all of that work to get there. An arithmetic mistake, who gives a shit, right? Like if you add wrong, I see the students do it all the time. I had students in my Cal 2 class tell me that 3 times 3 was 6. I didn't even take a point off. He did all this work. He got to the end and he had 3 times 3 and he put 6 down. I was like, whatever. I put a little star there so he knew. I underlined it, and give me a break. Like a Cal 2 student doesn't know what 3 times 3 is, but I don't take points off like that. Not